Everyone, we are moving on to derivatives given parametric equations. So we talked about this a little bit in class, where if you are trying to find dy dx, but you have two functions in terms of t, you can divide dy dt over dx dt. The dt's will cancel, and you just are left with dy over dx. All right, so that was a little bit of trickiness. So one big question is, why would you just not eliminate the parameter and then take the derivative? And while that is a valid point, it's not always possible to eliminate the parameter. Example being here. This is going to be annoying. This is going to be annoying. It's going to get, if you eliminate the parameter, you're going to have a horrible equation to differentiate. So it'll be a lot easier if I take the derivative in terms of dy dt and dx dt. Right, so first thing I'm going to do is solve for dy dt. Okay, so I'm just going to take the derivative of y with respect to t, which is going to be 20 t to the fourth minus 18 t squared. Right, then I'll take the derivative of x with respect to t, which is just 2t, and I'm going to divide these. So dy dx is going to be 20t to the fourth minus 18t squared over 2t, right, which simplifies to just be 10t cubed minus 9t, right? And that would be my derivative. Much simpler than eliminating the parameter, substituting, and all that, and then taking the derivative. You can try that out on your own, but it's going to be annoying. You have to do a lot of chain rule for that. Okay, then they ask us to take the second derivative, right? So not too bad, not too bad. The only thing is that, as you can see from above in the notes, okay, we're going to have to end up dividing it by dx dt. The reason being, we kind of need this in the form, actually I'll just scroll up. We kind of need it in the form d with the 2 here and then dx with the 2 here. Right, so what I end up needing to do is take my original derivative, okay, my first derivative, and if I differentiate with respect to t and divide by my derivative with respect to x, it ends up giving us that kind of x squared term here, if you want to think about this in algebraic ways. Okay, and in addition, I need something to cancel this dt out. Okay, so the reason why we do not do anything with respect to y is because, at least in this notation, y is not to the second power. You could think about it like that, whereas the d is. And so all we really need to do is divide by dx dt. Okay, so we take the derivative again with respect to t, and we divide by dx dt, which we already actually found. Right, so it's not hard, a little bit tedious, but it's not hard, kind of a lot to remember. Okay, so we already found dx dt to be 2t. Okay, that's just the derivative of x with respect to t. Okay, dy dx, we already found that to be 10t cubed minus 9t. So I want to find my second derivative. Okay, so I'm going to differentiate dy dx. So I get 30t squared minus 9. And I'm going to divide this by dx dt. Okay, so I get 30t squared minus 9 divided by 2t. Right, so the only thing you have to remember is to differentiate your first derivative and then divide by dx dt. Okay, and maybe, I don't know, if you look at this, is kind of what I use to help me remember that. I have x squared in the bottom, so I need to divide by x again. That's how I think about it. I don't know what helps you. All right, let's give another one a shot. This time I'm given some parametric equations and I want to write the equation of a tangent line. Okay, this keeps coming up. You got to remember how to do that at a specific point. Okay, well, first let's write out our point. Okay, so t equals 2 pi over 3. That doesn't actually tell me what x and y equal. Okay, I need to write this in terms of x and y. That's a tangent line. All right, so I need to know what's happening at x at 2 pi over 3, which is 5 root 3 over 2. I need to know what's happening at y at 2 pi over 3, which is negative 3 halves. So all I did was I took 2 pi over 3 and I plugged them into my equations. Okay, so this is my point. Okay, my point is 5 root 3 over 2 and negative 3 halves. That's my point. I also need a slope. Okay, so I need to find what dy dt is. I need to find what dx dt is so I can divide them. Right, so dy dt is going to be negative 3 sine of t. Dx dt is going to be 5 cosine of t. Okay, so I just took the derivatives. Hey, we could reduce this if you want to be negative 3/5 tangent. It's kind of up to you. If you want to use, if you're more comfortable using tangent, then you can use tangent. And I want to evaluate at 2 pi over 3. Okay, so I'm going to evaluate dy dx at t equals 2 pi over 3. So when I plug 2 pi over 3 into here, I get negative 3 times square root of 3 over 2. On bottom, I get 5 times 1/2. And so this will simplify to negative 3 root 3 over 5. All right, so this is my slope. So now I go back to my original point slope form. So y minus y1, so y plus 3 halves, equals my slope times x minus x1. All right, so tangent lines keep coming back. You have to remember how to do them in all different kinds of forms. Okay, one more on this page. Now I want to know all points of horizontal and vertical tangency. Okay. So a horizontal tangent is when my derivative equals 0. Okay, you all know that. And a vertical tangent is typically when your derivative is undefined. Okay, so what this means, now we're going to take this and apply this to parametrics. Okay, so if dy over dx equals 0, really what that means is dy over dt over dx over dt equals 0, meaning dy dt equals 0. Okay, so for a horizontal tangent, I need dy dt to equal 0. Likewise, for a vertical tangent, I need dx dt to equal 0 because that's what's on the denominator. Okay, so that's how I'm going to approach this. For a horizontal tangent, I need dy dt to equal 0. Okay, so first I need to figure out what dy dt is. So dy dt is going to be 2t minus 8. I need this to equal 0, so t equals 4. Okay, now it asked me to find a point. So a point is not a t value, a point is an x and y coordinate. So now I need to take 4, plug it in for x, plug it in for y. And when you do that, you end up getting 24 and negative 7. Okay, so I plug 4 in to find x, I plug 4 in to find y, and I get my coordinate. All right, let's do the same thing except for my vertical tangent. So for vertical, I need dx dt to be 0. Okay, and again, that's because dx dt is in the denominator. So dx dt is going to be 6t, okay, I don't know what happened. 6t minus 6, which has to equal 0, so t is going to be 1, and once again, I have to plug that in to find my point, which is going to be negative 3 and 2. Okay, so now we're going to look at arc length, and so we learned arc length earlier in the year as the integral of 1 plus my derivative squared. And now we're going to apply this to parametrics, and so we're going to rewrite this as dy dx. Okay, and just like before, we're going to rewrite dy dx in terms of dy dt and dx dt. Okay. Now all I'm going to do at this point is distribute the squared, so I have squared on top, squared on bottom instead of just one big fraction. I get a common denominator, combine my terms. Okay, and then this is kind of the tricky part. I evaluate my square root for the denominator, so this is dx dt. Okay, and originally my integral was in terms of dx, but I want this in terms of dt because t is my variable. And so I kind of pull this out of thin air. Okay, I say that dx dt is equal to, dx is equal to dx dt times dt. Okay, so the dt's would cancel and you're left with just dx. So this is totally fine, haven't broken any rules. That means that dx dt and dx dt cancel, so I'm just left with this, and this is the equivalent of f prime of t and g prime of t, okay, where the derivative of x is f and the derivative of y is g. Okay, you don't have to call it that, but that's what they decided on. All right, so the arc length for parametrics is just the derivative of x with respect to t squared plus the derivative of y with respect to t squared in a square root and then the integral. Okay, so it's very similar to your original equation for arc length, except you have two equations, so you gotta square them and add them together. All right, they ask us to write an integral expression, which is nice. They don't actually ask us to solve, of the arc length of my parametric equation here, x and y. So first thing I got to do is find some derivatives. So I'm going to start off with big L for arc length. That's going to be equal to my integral. Now they gave me my bounds, 0 to 4. Big square root. Right, so I have to evaluate the integral of x, which is going to be 5e to the 5t plus 2 squared, plus, now I have to evaluate the integral of y, which is going to be 6t cosine of t squared. Don't forget that chain rule, squared. Close the house with respect to t. Right, and that is it for arc length. So they didn't ask us to evaluate, but you do have to remember to put your derivatives inside. Right, and we'll explain a little bit more why on that in the next video. All right, that's it. See you all later.